This is almost midnight, like 3 minutes to midnight. I just finished grading Regents Physics Quiz 4 and AP Physics 1 Quiz 4, and also finished making the tutorial for AP Physics Quiz 4. Now I'm going to make the tutorial for Regents Physics Quiz 4. The only reason I'm doing it is because I want to give you 100% of chances to get 100 in exam 4, which is kind of tomorrow, because this is 2 minutes to midnight. Let's go over problem number 1. Vector 1, vector 2, and vector 3. All you need to do, I ask you to use the ruler to show me the displacement vector. And the displacement is the shortest distance from initial point to the final point. The shortest distance between initial to final point. You take the ruler and you measure it. And the ruler going to give you this is 3.5 centimeter. And then I give you scaling factor 3.5 centimeter, and centimeter to meter. I gave you the scaling factor 1 centimeter, 4 meter. Is this cancel? 14 meter. Okay, anything between 13 to 15 meter, I accept it because this is measurement. You can also do it by math. There are two ways you can do this by math. One is the displacement is the shortest distance. Displacement is the shortest distance between 2 points. This is how you write it. Displacement is the shortest distance between 2 points. You can use this formula, or you can also write displacement, the magnitude of the displacement. All right, so you can write x2 minus x1 squared plus y2 minus y1 squared. All right, so this is the magnitude of the displacement. Displacement give you what? Magnitude, which is 14 meter, and it gives you also the angle. You take the, in this case, I did not ask you to use the math. I asked you to use the protractor. You place the protractor over here, and protractor gonna give you 22-degree angle. We exactly know what 22-degree angle means. 1.8. This is 1.8 centimeter. 1.8 centimeter. You didn't even have to do that. All you needed to do, put two dot over here. The displacement is shortest distance between initial point and the final point. All you needed to do is connect them. All right. Okay, and measure how much is this one. So this one would be 3.5. So this is 3.5 centimeter. So you come over here and you want to write 3.5 centimeter times centimeter meter. 1 centimeter is 4 meter. Cancel. Why is that? Because I wrote that 1 centimeter is 4 meter. So this is 14 meter. So I ask you to write 14 meter over here, and I ask you also find the angle. So you're going to take the protractor and you're going to find the angle. Angle is exactly 20 degree. So as you see, the x-axis sitting on the x-axis, and the angle is exactly 20 degree. So I'm going to just go ahead and write 20 degree. A toy car initially moving 1 meter per second uniformly accelerate to a speed of 4 meter per second as it moves down 5 meter, right? So a toy car initially moves at 1 meter per second. So vi is 1 meter per second, and bf is you see 4 meter per second, right? Now they ask you to find the magnitude of acceleration. So what do you know? Vf squared is equal to vi squared plus 2ad. What's that? You have to sleep, baby. Okay. All right. You have a NYU in the morning, right? Vf squared is 4 squared is equal to vi squared is 1 squared plus 2a, and d is 5. So 16 is equal to 1 plus 10a. So 15 is equal to 10a. So a is equal to 1.5. So 1.5 is option number 2. So you're going to write 2 over here. Move on to problem 3. A car initially moving at 20 meter per second, right? You're going to write down whatever you read uniformly brought to rest. So bf is equal to 0 meter per second by you pressing the brake, right? So in the beginning you were moving 20 meter per second. At the end your velocity is 0 because you hit the brake and the car is stopped in 10 meters. Now, what is the acceleration? Again, I ask you the same question. Bf square is equal to bi square plus 2ad, and vf square is 0 square, because this is 0, is equal to vi square 20 square plus 2a, and d is 10. So you are finding 20 square divided by 20. So which is 400 divided by 20. So this is 20 meter per second square, and that is 1, right? Now that takes us to problem number 4. You're gonna drop a brick from a rest from a top of a building. So you're gonna drop this guy from a top of a building which has a height h. I ask you at 1.2 second, right? Uh, the how much distance does it fall? So d is equal to half at squared. I ask you to use negative 10 for acceleration due to gravity. So you're gonna write, you're gonna write half negative 10, t is 1.2 squared, right? So you have distance. I ask you to take the distance. So 5 1.2 squared. So 1.2 squared times 5, and that is 7.2. So distance, it falls 7.2. So I'm gonna just go ahead and write 7.2, of course, second. um, what does it ask? Find the magnitude of distance, right? 7.2 meters. 7.2 meters. Okay, number 5. That takes us to number 5. Number 5, you throw an object, right, from height h. You throw something upward, right? That means 90-degree upward with respect to x-axis. 90-degree with respect to x-axis. um, so you're done with 1, done with 2, done with 3, done with 4. Now let's go to 5. 10 meter per second, right? What is the maximum height? So it's going to create like a parabola type of thing. So the maximum height, remember, vy is 0. So to find the maximum height, vf square is equal to vi square plus 2ad. Of course, you're going to use the y component, give you vi. Of course, at the max height, this is 0. vi is 10 square plus 2 times negative 10d. So you have 100 divided by 20, which is 5. So d is 5, and that's how you want to solve the problem. So option number 2. Number 6 is 2 students, right, doing the lab, and they are releasing what do you call it, a ruler, and the distance fall is 5 meter. So d is 5 meter, and the time it takes is 1 second. They are trying to find the acceleration. D is equal to half at squared. Now they try to find the acceleration, so I'm going to isolate the acceleration. So 2d is equal to at squared. A is equal to 2d over t squared. So 2 times distance is 5 and time is 1 square, so it's 10. So you're just going to say the answer is 10, so which is 1. In the future, you can do both things. You can circle over here and write over here. That way it's going to be easier for me in case I cannot read your handwriting over here. I can look at over here. Which graph the positive, the decreasing positive velocity. The velocity is, let's say, 20 meter per second, 19 meter per second, 18 meter per second, 15 meter per second, 10 meter per second, 9 meter per second, 2 meter per second, 0 meter per second. How? Because you can draw a slope which is horizontal. And what is the slope of a horizontal line? 0. So the velocity is 0. You cannot draw a slope which is horizontal over here. This slope, I don't know what it is, but this is not 0, probably 20. So that from 20 to velocity is 0. How that possible? Because acceleration is down, velocity is up, so the object is slowing down from 20 to 0. This graph object is slowing down. All right, so number 7 is 4. Number 8 is the easiest problem. So I told you that v initial sometimes can written b initial, or sometimes called b1, or sometimes called v naught, or sometimes called v initial. Okay, so they all are same thing. So v naught could be 20, v naught could be, I don't know, 10. V naught is some velocity. So we see that B naught is something. It could be 20, it could be 10, it could be 50, it could be 100, it could be 1,000, it could be million, doesn't really matter. So this one is, if this one is velocity, this cannot be acceleration. Okay, if this one is velocity, this cannot be acceleration. If this one is velocity, this one cannot be acceleration, because this one has a positive slope, not zero. Okay, however, this is velocity, so this can be acceleration because this has a negative slope and this is negative. So there is no other thing even close to this one. So this is the right answer. We're gonna write D. Now come to this problem. This problem, the car Y. The car Y, if you want to write the equation, how are you gonna write it? BT is equal to T, right? And the and this is the car Y. This is the car Y. The car X, you can write V is equal to 20. So if you draw a DT graph, then of course the car 2, let's say this is V initial is 20. It doesn't matter. You can say 20. So this is 20. You can say this is 20T, and this is 40. This you can D. This is Y is half T squared. Okay, so now we want to know that which car at 20-second ahead. Of course, car X. Why is that? The car X has a higher area than car Y. Why is that? Car X has BH, which is bigger than half BH. How BH is bigger than half BH? Let's say this is 20. 20 times 20, which is bigger than half 20 times 20. So that this is 400 is bigger than 200. In fact, the car X is 200 meter ahead of car Y at 20-second. At 40-second, of course, the car Y is ahead of car X, is because look at the position function. This one is accelerating, but it takes time. It takes time to beat car X, and the time is more than 0 second. In fact, the time is 40 seconds. 40 seconds, the car Y is finally going to be ahead of car X. Now, finally, we are entering to easy problem. So that takes us to the part 2, and part 2 is the easiest part, the problem number 10. So Mr. Berry is throwing a ball from 30-meter tall rooftop with 90-degree. He throws something with 25 meter per second, and he want to find 4.5 second. He want to find velocity at 4.5 second. Now 4.5 is here, 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 here. He does not know. So one thing he know, at max height BF is 0. That's given. But he assumed that max height the time is not 4.5. You're gonna find the time at max height. So VF is equal to VI plus AT. At max height velocity is 0. Right? 25, which is the initial velocity, minus 10t. Oh, this is 2.5. If the time at max height is 2.5, here the time is, of course, 5 seconds. That means the velocity 4.5, we have to find velocity right here in the middle of max height and right here. That's where we're going to have to find the velocity. Well, that's very easy to find the velocity over here. So velocity VF is equal to VI plus AT. BF is equal to VI 25 minus 10, 4.5. So BF is equal to 25 minus 45. So BF is equal to negative 20 meter per second. So here velocity is negative 20 meter per second. You didn't have to do that much, but we did it because just want to give you some understanding. 10, 11. What is the distance the ball moves at 3.7 seconds? The best way to do velocity versus time graph, and take the absolute value, and that would be the distance. Now you know this is 2.5. How do you know? I explain it over here. Here 2.5, here 2.5. So here is 25. So this area is half BH plus we're going to find this is 3.7. So now this is also half BH, and this is, we're going to say distance. If we take the absolute value, which will do half, B is 2.5, H is 25. Now plus half, B is 1.2, and H is at 37. BF is equal to VI plus AT, right? So VF is equal to VI 25 minus 10, 3.7. So 25 minus 37. So 25 minus 37 is 12. So uh, so 3.7 minus 2.5. Okay, all right. So this is 12. It's too good to believe, but hey, I get what I get. 6. So you have uh, 0.5 times 2.5 times 25, and that is 31.25, plus you have 1.2 times 6, and that is 7.2. So 7.2 plus 31.25, and that is 38.45. 38.45 is the answer. 38.45. I'm gonna have to put some paper underneath so that it's easy to write and the writing is nice. The acceleration at the top of the parabola, acceleration over here is z, which is -10. Velocity is 0, but acceleration is -10. Think about it, why acceleration at the top has to be -10. If the acceleration on the top, if velocity is 0, why velocity is 0? Velocity in the y direction, because look, acceleration everywhere is -10, everywhere. However, from here to here, from location A to B, velocity is positive. So velocity has to fight with acceleration. That's why A to B, object slowing. Now B to C, the velocity is down. Now since there is acceleration even at location B, that acceleration will create the velocity. So this velocity is no longer going to be 0 at here, and since there would be a velocity, since there is acceleration, that velocity would be keep getting, magnitude would keep getting bigger and bigger. At right here is 25, right here is going to be -25. From 0 to -25 is this one at the same direction. So this is speeding up. Please understand this, very important. So I'm going to just write -10 because we have been using that. The ball distance is metered. 13 is, what is the distance the ball move from 0 to 5.5 seconds? So I'm going to do this way, and I'm going to say this is 5.5, and look, 5.5 is right here. This is, we already discovered, this is 2.5, this is 5, right? So 5.5, this is 6 seconds, the ball touches the ground. So 5.5 is near the ground. Okay, so 5.5, this is 2.5. So we have to have this one, we know this one, this is VT. This is the best way to find. This one we already found it. If we remember, we can find it from here, 31.25. So this one, 31.25. Now find the velocity over here. VF is equal to VI plus AT. So VF is equal to VI 25 minus 10 and 5.5. So 25 minus 55. So 35, 45, 55. So minus 30. So half a BH plus half BH absolute value. So this is 31.25 plus half. B is 5.5, 5.5 minus 2.5, which is 3, and H is -30. We're gonna make it positive anyway. This is 1545, 31.25 plus absolute value of -45. So 31.25 plus 45, so 31.25 31.25 plus 45, which is 76.25. So answer to this question is 76.25. That takes us to problem number 14, and problem number 14 is probably the easiest problem here. You are throwing something upward from 30 meters above the building, which you have been doing it for from problem 10 to 13, 25 meters per second, right? At the same moment, someone from same height, also from 30 meters, dropping, right? Dropping it. Okay, so this one takes 6 seconds, and dropping it from 30 meters gonna take how long? 1.7, right? So this one will hit the ground way before this one. So the only time after how many seconds will the two ball be at the same height? 0 second. At 0 second, at t equal to 0, this one 30 meters above the ground, and t is equal to 0, this one 30 meters above the ground, right? So then let's solve the problem. The problem I can, on Friday, I can change it. I can ask, okay, so if this one, all right, if this one you throw it same way, and it takes 6 seconds later it hit the ground, right? Because you throw it with 25 meters per second with um, from the rooftop, which is 30 meters tall, whose height you have to drop the ball so that this one also touches the ground at 6 seconds, right? So now then you have to find h. In this case, h would be 180. You have to drop it from 180 meters so that this will touch the ground at the same time. But this is not the case. This one touched a million uh, moment later than this one, because this one immediately touched the ground. This one touched the ground 6 seconds. This one took only less than 2 seconds, because this one is dropping, right? And this one has to go extra path. So this one took forever, this one did not. So only one location their height is same, no other location. Now the next question, problem number 14, we're gonna say t is equal to 0 sec. Number 15, at the same instant, Mr. Beatty throw the ball from the top of the, so this one, another student drop this one, right? At that instant, what is the velocity of each ball? One velocity is 25 meters per second, the other velocity is 0 meter per second, because dropping is 0 meter per second, and this one throwing is given. We're gonna do number 16 very quickly. I'm extremely tired now. It's 12, almost 1 in the morning. Almost 1 in the morning. Okay. All right. So find the position at 9 seconds. So 9 seconds is between 8 to 10 seconds. We have to find the position. So position is in meter. So 8 comma, I see 8 comma 5, 8 comma 5, and 10 comma 2, 10 comma 2, h and k, and x and y. So y is equal to a x minus h square plus k. Y is 2 is equal to a x is 10 minus h is 8 square plus k is 5. So you have negative 3a. We have to find the position. So what are we doing? Maybe we are doing the right thing. I don't know. I have no idea. This is 2 4, so this is 4a. So a is negative 3 over 4. So y is equal to negative 3 over 4 x minus 8 square plus k. All right, now let's see at what second? 9 second. So you're gonna write 9. K is how much? K is 5. Hey, my brain is not working. So p of 9 is equal to minus 3 over 4, 9 minus 8 squared plus 5. So p of 9 is equal to minus 3 over 4 plus 5. So 4 minus 3 plus 20. So 17 over 4. 17 over 4 is 4.25. So you want to write 4.25 meter over here. Find the velocity at 9 seconds. All right. So what do we know? We know that here is negative 3. Why? From 5 to 2 is negative 3. So a is half bh. So negative 3 is equal to half. 10 minus 8 is 2. H is velocity. So velocity is negative 3. What does that mean? I go over here. Velocity is 0. Velocity is 0. Velocity is negative 3. Velocity is negative 3. So I come over here, and then this is, that's it. So I know this is negative 3, and this is 0. Okay, so what do they ask you? Find the velocity. How can we find the velocity? By velocity function we can find the velocity. Vf is equal to Vi plus At. So now Vf at and right here at 8-second velocity is 0, so we're going to write 0. Acceleration is negative 3 divided by 2. Okay, so that is 1.5. So acceleration is negative 3 divided by 2. And then t minus at 8 velocity is 0. At 8 velocity is 0. Don't forget this kind of thing. B of t is equal to negative 3 over 2t 4 plus 12. So v of 9 is equal to negative 3 over 2, 9 plus 12. So this is negative 3, 4.5 plus 12. So 13.5, 4.5 times 3 in 13.5, negative 13.5 plus 12. So negative 1.5. So I'm going to write negative 1.5. Now at 5 seconds, we're going to try to find the acceleration. So acceleration at 5 seconds. So 5 seconds is from 4 to 6. 4 to 6, how much did it move? From 2 meter to 4 meters. So it moved 2 meters. So if it does move 2 meters, so area is half bh. So 2 is equal to half 2h. So the velocity is 2. 4 to 5 velocity is 2. So at 4 velocity is 0. At 5, at 6 velocity is 2. So this is the velocity. This is the area. This is 2. Okay, now what are we going to do? We're going to find the acceleration. So 2 minus 0, this is 2 divided by 2. So acceleration is 1. So acceleration is 1. Acceleration is 1. Acceleration is 1. Okay, now finally 19. 19, the graph shows. So this is the easiest problem. Now look at here, right here. At what location the object is at the origin? T is equal to 0. But of course, that's not what I asked. What time? Again, the uh, the graph is at the object is at the origin. Okay, now let's see the area over here. Half bh. So half b is half, and h is negative 1. So this is uh, 1 over 4, negative 1 over 4. So this is negative 1 over 4. Multiply by 2. So this is half. So this area is negative half. So now what about here to here? Here to here, what is the area here to here? Half bh. So half b is 2 minus 1. H is 2. 2 to cancel 1. So the area of blue is 1, right? So then there has to be a t where the area is positive half. So that negative half, positive half cancel, so that the object is at origin again. So how can we discover that? Well, by half bh. Okay, at the time t, there exists a time t where the area is only positive half. Okay, in between 1 to 2. Between what? Between 1 to 2. Between 1 to 2 seconds. Well, I don't have to solve it. That's it. Okay, number 20. Number 20, a body is moving. Okay, a body is moving with x direction uh, from the origin. Okay, with the speed. So this is our let's say this is our velocity versus time graph. Body is moving 24 meter from 0 to 1 second. After that, it accelerates negative 6. So like this, accelerating. So now what we're going to do, we're going to write d is equal to d initial plus vit plus half at squared. What is d? D is vit. From here to here there is no acceleration, So half at square is cancelled. So D is VI. VI is how much? 24. How many seconds? 1. So this is just 24. So you're going to write 24 plus VI at right here, 24. T is how much? T is, this is at 11 seconds. It says at 11 seconds, right? So 11 seconds. 11 minus 1, which is 10. Plus half. A is how much? A is negative 6 at 10 squared. So 24. D is 24 plus 240. 300 minus 300. So D is 24 minus 60. So 60, 24 minus 60 is minus 36. So this is minus 36. It's almost 1 in the morning and I just finished the tutorial. I'm gonna just I'm not sure whether I'll be able to post it tonight, but anyway, make sure you try your best to get 100 on Friday, which is tomorrow.